Well, good afternoon, Mr. Lange.
Hey, Mike.
Hopefully, it's not incredibly hot where you are. What's the temperature? What's your Ecobee reporting for the temperature right now?
I think the official temperature is, stand by. That's not bad. It's about 85.
Perfect. So,
sorry about that. 55, 27.
Thank you. We're glad you made the conversion for us as people
I weigh 100 kilograms.
So Guelph, Ontario is a little bit warmer than that. So we're sitting at about 32 degrees. And I'm looking forward to doing a 40K road bike after this. And maybe I'll get rained out. There's rumors of rain. Maybe that would be a good thing. So we want to thank everybody for joining Will and I today. We're going to be talking about electrification. We're going to be talking about the benefits of electrification, and we're going to talk about some new reports that are out and some exciting things that are happening in not just Canada, but North America and honestly, the entire globe. Will, do you want to take a quick second and just introduce yourself to the audience, who you are, what you do?
Hi, Will Lange. I work for these guys, WaterFurnace International in Fort Wayne, Indiana. I live in Bentonville, Arkansas, and spend most of my time consulting with utility companies and showing them how geothermal can help them and helping them implement programs to incentivize homeowners, contractors, manufacturers to deploy geothermal heat pumps.
Perfect. And I'm not sure how long we've known each other, Will. It's been a while. I want to say it's been 10 years. We pretty
about 10 years, yeah. Yep.
Yeah, about 10 years. So I'm Michael. I think I probably know most of the people attending. Those of you who don't, hello on behalf of myself and Eden Energy and Will and the WaterFurnace gang. I've been with Eden Energy now for 20 years. I am the technical services manager. I'm also responsible for field training and startups. My specialties is in heat pumps and hydronics, and pretty much that's what I am responsible for. Eden as a company has been around since 1981. We have a full technical team on staff. We have 2 professional engineers, and Grant Blackmore, who is the owner of Eden Energy, is very focused on that customer experience, whether that customer is an engineer, a builder, or a contractor. And that's a big ethos of what we do. A little bit of housekeeping. If you have questions as we're going along, there's a little questions window where you can type that question in. We're going to do our best to answer all the questions depending on timing during the presentation. I can assure you any questions that we get, we will answer. It may not be as part of this. You should all have my email address. So if you have a question, even a week from now, you're like, hey, Will had some great comments and I wish I could ask them, reach out to me and Will and I would be happy to connect with you. As far as handouts goes, there's a brand new report that came out from Dunsky and an HREI, and that's actually going to be part of our presentation today. So that is available as a handout that you can download. Another presentation, which is a quite large multi-part presentation, is the Enbridge study. So it was a field study of ground source heat pumps that Eden Energy worked with Enbridge on. If you'd like that handout, or if you'd like this PowerPoint presentation when we're done, then by all means, when I follow up with you after this presentation, feel free to reach out and get a copy of it from us. So I've kind of already covered this. We're going to talk quite a bit about what HREI and the Dunsky report is saying. We're going to talk a little bit about the Enbridge project, and then we're also going to talk about the benefits of electrification and how that's important in Canada and frankly North America or even around the world. So right off the bat, we want to talk a little bit about ground source heat pumps. I think most of the people in this presentation know what a ground source heat pump is. But for those that don't, we're going to spend a few minutes on this. So when Will and I say the basics of a ground source heat pump, we're not talking about, hey, it's a cabinet and it's got a ground loop. We're talking about the fact that ground source heat pumps are one of the most efficient ways that you can heat and cool a space, period. And there's a lot of research out there that supports that. And there's a lot of anecdotal commentary that says it's not. And we're going to talk about that and share some real numbers and data so you can get a better understanding of that. As a general rule, for every unit of energy with a ground source heat pump, you're going to get about 3 to 4 units back, whether you're doing a 2-stage or a variable speed or a air to water or a water to water piece of equipment. As much as Will and I are big fans of ground source heat pumps and water furnace and geothermal, the one big detractor is that unfortunately ground source heat pumps are more money. And it's just one of those things that we have to discuss, we have to get around. We're going to touch a little bit on it today. It's not really the purpose of this training, but the reality is that even despite that upfront cost of a ground source heat pump, it does make sense to go that route. There is significant savings there. And not only is there savings, there's advantages from the standpoint of decarbonizing Canada. There's an advantage to utilities. And Will's going to talk about that with me throughout the next hour. So obviously that high first cost upfront is a barrier for Canadians, for Americans, for Europeans, but there's certainly different ways that you can get around that. And thanks to the newly released Dunsky report, we've got some really good data that we can reflect on and talk about as we move along. So it should come as no surprise that as Canada and the United States and Europe try to decarbonize, try to get that green footprint, to save our planet, ground source heat pumps are going to be a critical part of that. The other nice thing about a ground source heat pump is, Will talks a lot about this in his presentations, as do I. In cold climates, some heat pump technology, it's not very adaptable, whereas ground source heat pump technology is not tied to outdoor air temperature. So ground source heat pumps are very effective when we're facing the challenges of cold temperatures like we would have in Ontario or in some of the northern parts of the United States. The other thing that's significant is this results in savings, and I kind of talked about that a second ago. There's savings to the end user, there's savings to the utilities, there's savings to Canadians on a whole, because the reality is as more and more early adopters and Canadians adopt geothermal technology, it's going to result in significant infrastructure savings for all Canadians. So if you look at the Dunsky report, which again is available as a handout, you'll notice that if we actually saw more Canadians adopting it, we're going to see savings that are significant. You're talking like south of $100 billion, which works out to be about $40,000 per ground source heat pump installation. So obviously, we've summarized the numbers a little bit. We encourage you to read the report. Any questions you have, reach out. Will and I would be more than happy to have a conversation with you about it. One of the other things that's really interesting when we look at ground source heat pump is to actually talk about the adoption rates. There's a little bit of gray of what is the adoption rate. Well, the reality is, again, courtesy of the Dunsky report and some of the work that's been done in different jurisdictions, we don't have to guess as to what that adoption rate looks like. Unfortunately, as a Canadian, I can say we're towards the lower end of the adoption rate. We're at 0.01% in Canada. If you look at Sweden, they're the leaders when it comes to adopting ground source heat pumps at 23%. So to put that in perspective, that's saying 20 to 25% of homes in Sweden actually have ground source heat pumps. And of course, Will is here, so we can't stop talking about the United States. The United States and Austria are actually at 0.06% adoption. So there's a reason that there's a big difference in the adoption rate of ground source heat pumps, which is what Will's going to talk about beneficial electrification. The way that we're going to increase this is through policy change, and really it's going to take a multifaceted approach to get ground source heat pump education higher, not just with the contractors, but with utilities, with end users, and of course, with our politicians. Certainly Will's favorite anytime we have to drag a politician into the discussion. One of the things I do want to point to, and we see this a lot, is in a lot of cases, people will point to adoption numbers of, okay, what is the adoption rate of ground source heat pump technology versus utility rates? And one of the interesting things you can look at is that Sweden is a leader in the adoption rate at 20 to 25% of homes. And in a lot of cases, people will say, well, yeah, but they've got lower utility costs than we do. So you can look at this chart and you can see that's actually not the case. What's driving the adoption in the United States, and in this case, we have New York State on here. You can see the utility rates for Canada, Austria, Germany, New York State, and of course, our friends in Sweden. What's driving that adoption rate or changing the minds of consumers and utilities is not the actual cost of what it is. They're looking at the policies that have been put in place to make it easier for them to do that. So we're going to talk about a real world data validation scenario with Enbridge. So of course, Will and I want to give shout out to Enbridge. Specifically, we want to give kudos to 4 people there. So Mohammed and Atil and Matt and Jeff all were, I'm going to call them the key stakeholders that worked with Eden Energy and with WaterFurnace as part of putting together some pilot projects. And we're going to look at some of that data to see, did Enbridge's work actually validate, the fact that ground source heat pumps do make a lot of sense. So if we look at the project, they had 4 new construction sites. The systems were done in 2017 with final occupancy coming in 2020. As far as the equipment that was selected, it was multi-stage equipment as well as variable speed equipment. They were able to collect a significant amount of data using technology called Symphony. And Will and I will talk a little bit very briefly at the end about this. And the other thing they were able to do is that Mohammed and his team were actually able to collect even more data points through custom controls they put on site so they could really collect a lot of data. As far as system sizing and design, pretty standard. They sized it for 80% of the load. They had 10 kilowatt backup heat on them. So they weren't doing anything out of the norm. They were trying to build a standard platform to see how would these heat pump installations compare to what they're used to, which would be a natural gas application. So I'm just briefly going to share a little bit of data on this. So if we look at their heating performance data, so on the left-hand side of the screen, you can see the variable speed compressor system. The green bar that you see across the top there is actually the COP of the system. And then the blue bar is the actual outdoor air temperature. So you can see what the overall COP, so the seasonal COP for the system on the variable speed was 3.8. And so to the point that Will and I were talking about at the beginning of this, unlike with some other technology, it's not tied to outdoor air temperature. That really is the simple answer as to why ground source from a cold climate standpoint makes so much sense. So you can see the overall seasonal COP was 3.8. And then on the right-hand side of the screen, you're going to see that was the 2-stage compressor unit. And you can see that its overall seasonal COP was 3.4. So they had very good performance between these 2 units on a heating side.
So Mike, just for the benefit of, there's maybe some folks out there that aren't completely up to speed on COP. That means, when you see a 3.8, that means you're getting 3.8 units of heat produced by the heat pump for every single unit of energy that you put into the heat pump. So really, it benefits to think of it as a pump that's pumping renewable energy, form of heat, up out of the ground. And in the next slide with the cooling, it's pumping that heat down into the ground. So that COP of 11, wow, that's 11 units of cooling for 1 unit of energy.
Yeah, the nice part about talking a COP number as well is it's a little bit more relatable than an EER number. It's much easier to explain to an end user or a politician. Hopefully we don't have too many politicians participating as we make some politician jokes here, but if you have to explain them the efficiency number, it's quite easy to explain the COP. As Will rightly points out, our variable speed unit that Enbridge had in the system, you can see it had a seasonal COP of 11. That's a pretty staggering number. Again, Enbridge was collecting 180 data points. Most of those collected through the Symphony system, but some of the data for some of the other things collected through custom controls that Enbridge did a great job at. And then the 2-stage compressor unit, you can still see at a seasonal COP of 7.2. So these are pretty impressive numbers, no question about that. One of the other...
Again, Mike, resilient to the weather and resilient to any changes in the climate.
Yeah, not driven by that outdoor air temperature.
A similar graph for other technologies, you would see both lines running parallel as the temperature goes up or the temperature goes down. The energy usage would track directly in proportion to that, but not in this case. Sorry to interrupt.
No, not an interruption at all. So obviously the ground loop is what does this, right? The fact we have a ground loop buried in the stable earth is what does this. That also, I'm going to use the word Achilles heel. It's also a little bit of an Achilles heel because the upfront cost of the equipment to an end user, we know through surveys that the Dunsky report did a great job of getting Canadian, American, Swedish, Austrian. They got feedback from stakeholders around the world to really articulate that, the end user's conception of the upfront cost, it was concerning to them. And the reality is that unless we can build policies that offset that cost, And part of those policies is getting utilities engaged so they can look at the systems, validate the systems, then figure out how as a utility do they get involved in that process. And so kudos to Enbridge. Enbridge stepped up and wanted to be proactive and part of that process to start to do the research. And it's great that they've collected this data on their end to show that, yeah, with this ground source heat pump, we've got really impressive numbers. Now, how do we work with HREI, OGA, and the various stakeholders to see if we can take this more mainstream as we try to improve things in Canada? So we don't want to scare anybody with this slide, but one of the things you certainly have to be conscious to is that the heat of extraction and the heat of rejection, which Will was just talking about. So in the winter time, we're obviously going to be extracting heat. In the summertime, we're going to be rejecting heat. It's not a 1-to-1 ratio. So really what you want to be conscious of is that right now the adoption on geothermal is not very significant in Canada. And if the stakeholders have their say, it's going to continue to increase dramatically. We do have to be conscious of making sure that we have the right people at the table, that they're doing a proper design, that the contractor involved truly knows what they're doing so that we understand this relationship between extracting and rejecting heat. As right now, Will might have one neighbor who has geo, but he could very well 10 years from now go, I got one guy in the whole neighborhood who's got gas, or whatever the case may be. So we certainly want to be conscious of that.
And Mike, you know, a lot of people don't realize this, but the core of the Earth has as far as we know, an inexhaustible source of heat. So in Canada, please feel free to pull all the heat out of the ground that you can, because it's over 5,000 degrees Celsius, the core of the Earth. And if you pull out too much, the folks in Texas, they're putting it back in. So don't worry about that.
Yeah, and I think it's a good point. You know, in individual houses, it's not a big fear. Obviously, if you're doing MERV buildings, multi-unit residential buildings, you know, there's no, you know, Will and I talk about this. With geothermal, there's no licking your thumb. There's no rules of thumb when it comes to doing the math. You have to do the math. You have to have a good designer engineer. And I just want to beat this home. You have to have a very good contractor that understands these concepts. We talk about this a lot in training. If you look at the biggest solar array we've got, we'll just talk about what it is. It's what we're standing on. It's the earth underneath us. So we just have to be conscious when we design things that it isn't a 1-to-1 ratio.
You know, interestingly, Mike, we did do a comparison of the GeoLink, which is the design software. It makes it very simple to figure out how big your heat exchanger should be when you put the pipes in the ground. Compared that to the actual data used and the temperatures of the loop, and we found that that software is within 5% accurate. So doing the math is mostly a matter of turning on your computer and putting in a limited amount of data and getting really surprisingly accurate output from that estimation tool.
Yeah, it's interesting. When I came into this industry 20 years ago, you know, there was a really solid think tank, but it was tied to key people. You know, you couldn't find a good geo pro in every city. You might find a really good geo guy in a like designer and you know, thought leader, I guess. There's lots of contractors, but if you had questions like, how would I do this? And software and frankly, just the evolution of time has made it a lot easier. The software that Will's talking about, that's no charge to our customers. So if anybody who's on this webinar would like to try that software out, reach out to me afterwards. We can do a little, you know, 30-minute webinar with you and run you through that software. And to Will's point, it's not hard to do. Once you've done a couple, it's a very, very simple process. It doesn't take a lot of time to do that extra step. No different than it takes a little bit of time to find a designer or contractor that actually knows what they're doing. So some of the learnings from the pilot, and again, you're welcome to reach out to me and we can give you all the detailed reports. We're really just skimming them down for a 1-hour presentation, is really the reduction in energy related costs. So there was a 25% reduction in energy related costs against air source heat pumps, against natural gas. It's significant. Right? There's this whole gray of, well, I could do this with an air source heat pump, or I could do this with whatever perpetual time machine I have, and I could compete with ground source. You can't trump data. Data is data. And what's nice for us as Canadians, especially being in Ontario, is having actual valid data for Ontario that takes the argument out of it. This isn't Will Lange saying ground source heat pumps are the greatest thing from an energy saving standpoint. Will and I can throw a lot of data at you. We're really happy that Enbridge did their own pilot, has their own data. I think we agree with most of their findings. I can't think of anything we don't, but even if we did, it's data, right? You can't argue with the numbers. You can argue with opinion, but raw data is raw data. So significant energy savings, which is really key to this. Obviously, we talked a little bit about the load imbalance. You have to be careful, but it's not a concern from the standpoint of the applications that we're looking at. And really from the whole, carbon effects, it's 100% reduction of on-site greenhouse gases. Now, the other thing that's really telling about this is the feedback from the end users that were in this pilot. I was on site for the final commissioning of this equipment, and I was on site for follow-ups. And it was really impressive to hear from the homeowners. I don't want to say they didn't understand the technology. That's not really fair, but there wasn't a house that I was just in 1 minute and out while the contractor checked the unit, replaced the filters, etc. They wanted to drink a coffee and talk to you about, this is amazing. I don't know what they were expecting, but they were so surprised how comfortable it was, how inexpensive it was, how pain-free it was. I think they thought there was going to be like NASA engineers and cosmonauts and astronauts in their basement putting this together. The reality is it is a simple system when done right. So as far as the construction process, go ahead, Will.
Yeah, when you think about putting a heat pump in your house, some of you have lived with air source heat pumps that every hour or so in very cold weather run as air conditioners for 5 or 10 minutes for a defrost process. And that has earned the heat pump industry. It's painted all heat pumps with the same color of paint. That, yeah, it's great for 45 minutes an hour, but then we're going to freeze while it defrosts and it's 20 below zero and my air conditioner's running. That's clearly, you may or may not know this, but geothermal heat pumps never go through a defrost cycle. But I'll tell you, it was very difficult to explain that to my wife because she froze through a couple of Texas winters with a heat pump that kept defrosting. And she would not believe that there was such a thing as a heat pump that didn't make her cold every hour. So I'll let you go on, Mike, but that's a broad brush that's been painful for us.
Yeah, well, and so Will's background pre-WaterFurnace, we won't name the manufacturer, but he was involved with an air source heat pump manufacturer and a good company. We're not bagging on them. I can tell you, Will, I can remember when in my younger years, we had an air source heat pump in our family home. And yeah, we've experienced that as well. So this kind of ties to the construction process. There's a lot to the construction process, but again, I'm going to hammer that point home just because the biggest Achilles heel that I see is not the equipment, it's not the engineering and design. I mean, that's all available to you. It's the contractor. And one of the things that Enbridge found from their study is making sure that they're able to get access to contractors who are qualified to do the work. Unfortunately, every year we will go to site and find jobs and we will experience what a high quality heat pump installation looks like when the guy doing it or the gal doing it has no business doing heat pump installations. They're not an IGSPA accredited, they're not an OGA member, they're not HREI certified, they haven't gone through the process, but they were able to get their mitts on some equipment and figured, it's a heat pump, or it's kind of like a boiler, I can make it work. So really the takeaway in the construction process is understanding the contractor. And again, we give kudos to Enbridge for having a really good process in place to make sure they had a very good contractor and making sure that everything went seamlessly for these homeowners. So at that note, I'm going to hand it over to you, Will, to talk for a little bit. And I'd like you to sort of talk to us about what beneficial electrification means.
Sure enough. Well, I call it here on this slide the watchword for the utilities in the 2020s, and I can't overstate that. It's popping up in lifestyle magazines, presidential speeches, congressional debates all over the United States. It was really started by an individual, Keith Dennis, at the Rural Electric Cooperative Association. And that idea has taken hold. Some environmentalists have renamed it environmentally beneficial electrification, but the concept remains the same. It's really just four things. It saves consumers money over time and or benefits the environment and or it improves, quality of life, the way things work, resiliency of the equipment, and it makes for a better or just a more robust grid. And we'll talk about the resiliency of the grid as things change with electrification. That's going to be where geothermal heat pumps play a major role. The other thing about beneficial electrification is that it appears to be inevitable. There is growing concern among a large number of folks that the existing fossil fuel industry is unsustainable. And if that's the case, then electrification is necessary. So we could, next slide.
One
Mike.
of the things that's worth noting there too, Will, is your quality of life. And I think there's a disconnect. And again, I'll walk it back to when I was on site and had the pleasure of meeting these homeowners. It was great that homeowner A had variable speed equipment. You can see it in the overall COP in excess of 11. That's fantastic. All the homeowners said the same thing. They all talked about their quality of life, the comfort. And I think that's important that we don't forget that as part of all the points that Will has here. The number one thing that we have to provide to consumers as we build policies and try and build a strategy forward is comfort. We have to make these consumers happy and comfortable, just like we want to be comfortable.
Well, there's a fun fact, Mike. It's 95 degrees Fahrenheit. What is it, 30 something in GTA today? Who wants to put on a 4-burner stove with gas burners? 85% of that heat just goes into the environment. It doesn't cook the food. The alternative may be inductive cooking, where 85% of the energy goes into the food and only 15% gets wasted into the environment. And that doesn't even talk about the air pollution from things like gas cooking. So these are all issues that are coming to the fore. And this slide really pulls a couple of headlines from the news that I never thought I would see, especially in my lifetime. It's the idea of a natural gas ban is something that strikes some of us as totally unexpected, but it is happening from California to the East Coast, New York State, very real gas moratoriums right in New York City and the surrounding areas. So it's happening, and it looks like that's a sore spot for a lot of folks, whether we like it or not. It seems to be happening. So with that mega trend in hand, understanding that, what should a gas utility do? What are you going to do if your business becomes illegal in some places or in all your operating areas? For the Vermont Gas Company, Vermont VGS, they've actually hired a team of folks to figure out what they're going to do when they're done selling gas. They're planning to get out of that business over the next 100 years. So good for them thinking ahead, but it's an interesting concept. What else could a gas utility do? Let's take a look. Well, when Coca-Cola could no longer put cocaine in their soda, they just changed it. And perhaps the gas companies can do the same. Instead of pumping gas to homes for them to burn or explode or whatever they do with it, perhaps they can pump thermal energy to homes underground using almost the exact same infrastructure. Mike?
Yeah, I think this is a really good handout because, again, not to give Enbridge a hard time. I think we've been actually pretty fair to them in this whole presentation, but it's an Enbridge ad, right? This is Enbridge. This is their own marketing sales pieces. So you see it in the United States, as Will said, with Vermont and with other utility jurisdictions. You have thought leaders in the utility side, specifically in the natural gas side, that are looking at ground source heat pumps going, how can we build programs that at the end of the day are beneficial to the end user, but let's not kid ourselves. It's also beneficial to the utilities. And, will dive a little bit more into that.
You bet. In fact, the 14 gas companies actually exploring how to distribute ambient temperature water to urban neighborhoods, what they're calling micro districts, geo districts, etc. This idea was explored by HEAT, who you see their organizational link on the left, a terrific advocacy organization that started out looking at gas leaks and mapping gas leaks, which are, I had no idea the magnitude of gas leaks in the US gas infrastructure was so dramatic. But then they started looking at alternatives. Some of that orange area you see in the lower left, those are gas leaks in pipes that were installed when Abraham Lincoln was president of the United States 150 years ago. When those pipelines fail, we're finding it's lower cost to put in geothermal heating and cooling heat exchangers underground instead of replacing highly pressurized gas lines with a volatile fluid. So maybe geothermal is an answer, especially in those urban areas with the ancient infrastructure. You know, something caught my attention at the beginning, Mike. We in this industry apologize a lot for higher first costs. Well, one thing Canada led the industry on was they did a study of what does it really cost to bring gas to a house. And those 5-figure numbers, and in some cases 6-figure numbers for an individual home to get a gas line, if you include those socialized costs, geothermal can be and often is much lower cost for delivering energy to a home. So I don't apologize for that high first cost anymore because it's really not higher than many of the alternatives for heating. So, well, you know you're doing okay when you see this. This got my attention. We must be having an impact. 15.
The other side of that, Will, is there's, you know, the ground source heat pump discussion, there's a significant ROI that comes into play there that can't be dispensed, right? And that ROI is often looked at it as what is Will Lange or Michael or anybody on this, what are you guys going to have back in your pocket? There's no payback, right? Like, you don't go on your furnace and your furnace doesn't start whipping out $10 bills at you, but there is an ROI. And the reality is there's a small subsection currently of Canadians that are you know, carrying that cost. And what really to me is really, you know, rewarding is seeing people like Mohammed and Jeff and Matthew at Enbridge that are doing the math that Will's talking about. They're actually looking at what is the cost for us to go into this community and run gas lines versus us to go into this community and put ground loops in. So instead of me paying for a gas meter and for a gas hookup to my house, instead I'm paying for a geo hookup. And the reality is it's better for consumers. And to Will's point, you've just eliminated that upfront, oh gosh, I really want this, but I've got this huge capital cost I can't afford. Well, Enbridge or the utility in Vermont or the other 15 that Will just alluded to can make that cost go away.
Exactly. So electrification really just boils down to two things that are about equal size. At least the data for the United States shows that they're pretty close to half and half. And those two things are right here. It's just transportation and heating. Transportation is half the battle, and heating buildings is the other half. Buildings are not cooled by gas, obviously. They're all electric cooling. And even in Northern Ontario, there are commercial buildings that have to have air conditioning because of the nature of their business. A fun fact, our factory in Fort Wayne, Indiana, is the heat balance is at 16 degrees Fahrenheit, which is pretty darn cold. That's -5 or so, right, Mike?
Yeah.
So we're cooling that building until we get to 16 degrees Fahrenheit. So yeah, heating is half the battle. And why have two systems? So if we go forward, Tesla, whoever else, Nissan, everybody, that's taken care of. We don't need to worry about transportation. They're selling lots of cars. That trend is gaining steam. Here's what we need to worry about. If we're going to electrify heating, we only have really 4 choices today. Resistance heat, same thing with a little storage maybe, some hot bricks, an air source heat pump, or a ground source heat pump. Take your pick. The question is, what makes the most sense to society, to the utilities, to the individual over the long run? And now is the time to discuss that. And let's take a look.
The other thing too worth noting there, Will, and you'll see this, my good friend and mentor, John Siegenthaler, talks a lot about this. You know, John unfairly gets painted as not the geo guy, which is completely untrue. I shouldn't speak for you, John. I'm going to apologize for speaking on your behalf, but we're good friends. You know, the reality is there are scenarios, and even Enbridge is seeing this, where gas is not a bad thing. You can build hybrid systems where instead of having a 5-ton geo, you might have a 3-ton geo or a 2-ton geo, and you may have some other secondary heat source, whether it's a a gas appliance or an air source or whatever the case may be. There's lots of different options there.
Indeed. And this, the next 3 slides are for argument's sake, and they represent the opinions of some experts. And it's wholly subjective, except for that left-hand column you see right there. Efficiency is efficiency. And those are seasonal types of numbers. You may look at, for instance, the air source heat pump with a 2. Well, if you see a COP for an air source heat pump of 3.5 in an advertisement or a brochure, that, please understand that's for 47 degrees Fahrenheit or 17 to 8, about 8 degrees centigrade. That's the temperature at which air source heat pumps are measured and advertised. That's the number. So if you're looking
just
at
pause you there, where we talked about outdoor air temperature, that's important. The COP that you see advertised, and it happens frequently, that's at 8 degrees. So if we're in Ontario in the wintertime, are we designing around an 8-degree design temperature, right? Whereas the ground source heat pump, it's not relevant. It doesn't come into the play of the discussion at all. There is no gotcha moment on, well, Will, your COP is 3.5, but we got to talk to your wife about the air conditioning that's going to be happening in the dead of winter.
Yeah, these numbers, these are like hockey. A high number is a good score, right? So in the case of resistance heating, it's very inexpensive to install, so the initial cost is very low. That's great for a homeowner. But where they have to pay for it later is in the operating costs in the right-hand column. You put in a kilowatt hour of electricity at whatever your cost is, which is very high. That's all you get out of it, is what you put into it. So that's pretty tough. Geothermal heat pumps giving you maybe 4.5 or more even units of heat for every unit of energy. That's pretty fair trade.
Yeah, so really where we'll see policies and utilities getting involved is to drive this number down. Right? This is where we need them, because they can help us to get that cost down, and it's to everybody's best interest that happens.
Exactly right. And then from a contractor perspective, I expect this to cause all kinds of argument and conversation, but realistically, a contractor can reap higher business revenue and profit, lower warranty costs, even use less talent and effort to install geothermal heat pumps. And bear with me, understand air source heat pumps require charging, field charging, and some careful management of that refrigerant. Geothermal heat pumps typically do not. So maybe they're easier. We know that the warranty costs and the maintenance costs on geothermal heat pumps are the lowest. So that really appeals to contractors in terms of callbacks, return trips, fixing problems. Properly installed, a geothermal heat pump should run for many, many years, about double, according to the US Department of Energy, the lifespan of an air source heat pump.
Yeah, and CGC has, CGC and HREI and other bodies have done their own, studies that support that number. Some people will get a little bit worked up about, well, that's not true. Where does this come from? It's a very simple answer. It's just like your refrigerator, like the refrigerator you put into your house. When's the last time the service guy came by? Like I've never had somebody work on my refrigerator. The reason for that is it's a factory tested, factory charged piece of equipment that when it leaves that factory, it's like leaving a laboratory. They have all the data, they know it's running. So in the case of WaterFurnace, that's how they put equipment out. So, in my role as a technical trainer and the guy who goes to the gotcha sites, 99% of the time, it's not the equipment, because I can make a phone call down to Will's friends and say, hey guys, I need that initial startup report, and I can see everything. So when Will talks about warranty and repair costs and how much easier it is and how much less expensive, there's no gotcha in that. The reality is that the way the factory makes this equipment is what makes the difference. It really shows in the end result.
So one of the problems with this slide, Mike, is the lower right-hand corner. Ground source heat pumps have been described as exclusive and for wealthy people. One of the things we at WaterFurnace and NEBA do is advocate strongly for incentives and makeup opportunities for low to moderate income installations. And we've had great success recently, particularly in the Northeast, New York State, Massachusetts, in finding, identifying, and providing heat pumps for low to moderate income people because they pay such a high percentage of their income for energy. So we're trying to fix that problem. It's great for business right now for contractors, but we're also trying to make sure that everybody can get access to this low cost heating and cooling solution. So, and from a utility perspective, yes, they will sell more electricity. They'll get more revenue from resistance heating than they will from a heat pump because a heat pump's more efficient. But they'll have to sell that electricity at the worst possible time, and they can't make more money doing it. And it ends up costing you, the ratepayer, because the infrastructure costs of providing peak heat for resistance heat will cripple a utility. And we'll talk about what happened in Texas, where 60% of the residents had resistance heat, and the cost that had during the polar vortex. It did bankrupt and destroy several utilities. But the geothermal heat pumps that operated at ground temperature, not air temperature, had a very favorable impact and continue to do so. So what's peak load worth to your utility? That's the question that has to be answered. Short-term revenue, sure. That's great to get resistance heat, but long-term success and resiliency lies in a more efficient peak load situation. So as a ratepayer, right here, you can see it, you're paying for peak load. That's what the utilities are charging you for. And you know that at 3 o'clock in the morning on a March evening, utilities are paying nothing to make that electricity. They'd love to have you use more. But on January 2nd, when it's 40 below zero, that's when they're really hurting. So this is sort of a value map that you could agree with or disagree with. That's my point of view. Next slide, Mike. So how did ground source heat pumps reach mass deployment? How do we go from a little bit below 1% in the US to 10%? Well, utilities drive the incentives through their rate bases, which means that whatever you pay for electricity, some of that goes towards incentives. It's already going there. We think a lot of that should be pushed towards geothermal heat pumps. They have access. In fact, in the United States today, there is 30-year capital available at 0% interest from a government-backed securities company for energy efficiency programs, and many utilities are taking advantage of that. In fact, last week, an Indiana utility added their name to the list of folks that are giving free loops to their members in their service territory. Free loops, just to put in a geothermal heat pump. That gives you an idea of how profitable it is for an electrical utility to have geo units on their lines. And you know, utilities drive choices based on what they provide. If there's no gas available, you're going to electrify your heating and cooling, one way or the other. So let's just dig just a little bit deeper, and I think we'll get to question and answers a little early, Mike. But here's, for 30 years, forever, the heating and cooling industry has been saying we have the most efficient this and that. I recall working on furnace projects to get 0.1% more efficiency out of a gas heat exchanger, spending billions of dollars. But the reality is nobody really measures equipment after it's installed, except what you see right here. Those are 8,551 heat pumps that we check every 10 seconds. We're taking 60 to 120 data points from every single one of those heat pumps you see on the map. And regrettably, we don't have this interface for Canada, but almost Canada,
Yeah, keyword, yeah. So
Yeah,
this data is
yeah.
being collected in Canada. So the installations being done by WaterFurnace dealers that utilize Symphony, which Eden Energy supplied at no charge for a very long period of time to get this technology adopted. We can't provide ground loops at no charge, but we can certainly say we will absorb the cost of Symphonies with the help of WaterFurnace to get this technology adopted so we can collect this data. Sorry, just wanted to throw that in, Will, but it's
Oh,
coming.
good point. We need to get this up north for sure. And I think this used to be part of Canada, but here in New York State, you can see this is at setting the cost of electricity, which is a good number for us in the US, at about 12.5 cents right here. And you can see that at 12.5 cents, it's about $2 a day to heat and cool a home in New York State. And that's heating, cooling, and actually most hot water for those 1,200 homes in New York State. So that's pretty good. Let's take a look at some individual houses like this one here. This is a 5-ton, 2-stage compressor and a home. So that would be in New York, a 3 or 4 bedroom residential home. It's costing them, they're right kind of middle of the road. They're at $40 a month. And you can see the actual kilowatt hours used for heating, cooling, and the fan, because the hot water is a free byproduct of the heating and the cooling, the compressor operation. It doesn't count the energy use, but that's also being provided. So 3.8 megawatt hours for that house. Take a look at how much fuel you use in your home, convert that to kilowatt hours, and see how that stacks up. I can guarantee, unless you've got a geothermal heat pump, this number is lower. Mike, next slide. Yeah, here's another one. That's a 5-ton variable speed. So you're getting a little bit more capacity for a little bit less energy, about 4 megawatt hours a year to heat and cool hot water. Some of those darker dots that you see on the map are higher energy users and some are lower. But again, for the entire state, 2 tons to 6 tons, fancy to not so fancy, about $2 a day. And as I mentioned, we have, since I've been talking, we've collected several terabytes of data on these houses in New York that we're logging and storing for 2 years. And we now can provide to utility companies with homeowners' permission. So that's kind of exciting. Mike?
Yeah, one of the interesting things to add to that too is, those of you that download and read the Enbridge report, or who already have, you'll notice that the homes, from an electrical usage standpoint, it was a couple of $100 a month, like period. That was it. And the reality is that, unfortunately, I live in the city. Enbridge hasn't offered to put a ground loop in yet for me, and it's going to be a bit tricky for me to do. And my hydro bill is a couple of $100. I'm paying the same for electricity here. The only difference is I got a gas bill on top of it. I'm not heating my house. So, this misconception of costs that are associated with ground source heat pumps. Are there ground source heat pumps that don't work as efficiently or effectively? Absolutely. Does it have very much to do with the ground source heat pump equipment? No. Does it have a fair bit to do with the application and design and installation? Oh yeah. So again, it comes back to that key of making sure that as stakeholders get involved and they draw the line in the sand, Enbridge says, here's a program we're going to run, and here are the stipulations. We want to make sure those stipulations result in comfort for the end user and satisfaction for the whole industry.
Mike, I think in 35 years of marriage, the only argument I've ever won was when my wife installed our first heat pump and she said, look at our electric bill, it's gone up. I said, well, show me the gas bill. And she very quietly retreated. And I haven't won an argument since then.
Well, I think she probably let you win that one, but
probably. Here's another good reason why geothermal heat pumps are good for utilities. And it's very simply, what are you going to put in the ditch? What does it cost to run all of those utilities to all of those individual houses safely, efficiently, effectively? And when do you have to replace those? How long are they going to last? What's the infrastructure life cycle? What if you could take one of those utilities off that list and dig just a little bit fewer ditches, or maybe even put geothermal heat pump heat exchangers in some of those ditches, as we're starting to see happen in Texas. So that's exciting. Just a sort of a thought exercise as you look at the expanse of homes. There's one more. Risk averse. Who wants to be the next Texas? For those of you that didn't know, the Texas grid is called ERCOT. That stands for the Electric Reliability Council of Texas. Last February, they were anything but reliable, and folks started calling them ECOT because they had to take the reliability out of it. 60% of Texans heat with electricity resistance heating, and at a COP of 1, when it's 20 below 0 and your design temperature is 10 or 15, that creates significant problems for the grid. And don't think for a minute that Texas polar vortex was isolated, either in terms of where it happened, because it happened here in Arkansas and Oklahoma and Louisiana, and also how often it happens. But that created 3 years of power cost in 1 week, and bankrupted utilities, destroyed their reliability records. And having lived in Texas for many years, I can tell you that the folks we know all had burst pipes. 90% of the houses in some neighborhoods had water pouring out of their ceilings just for those reasons. Things are changing. We've got to be up to date, and we can't rely on old technology anymore. So risk aversion. So what are the numbers? Peak load shaving. I'll give you a cooling number, and that's 0.6 kilowatts per ton. If you install a 10-ton cooling system using geothermal, your utility system will see a 6 kilowatt reduction in peak load. Now you add up 350 typical homes in Ontario, and at the heat of the summer, a day like today, that's a megawatt, about 350 homes. That's a megawatt difference in cooling peak load, which can be a lot. That's something to think about. So as this technology deploys, we're seeing it have a very powerful effect on the size of the infrastructure required to meet peak load. It's reducing that requirement. Seasonal load is interesting. For those of you that have a gas furnace and an electric air conditioner, you run your electric air conditioner today and for some period throughout the summer, and then you turn it off. And your electrical company has to maintain that infrastructure for gigawatts, really terawatts of power for the next 7 months while you don't use it. So seasonal load is devastating to electrical utilities. If you stop using your air conditioner and 100,000 of your neighbors do the same thing on September 1st, that leaves a giant infrastructure with no usage. And that costs money. It costs you money. So increased revenue. Switching from a gas furnace system in a climate a little further south than yours would typically create 15% more revenue going from a gas furnace to a geothermal heat pump for electrical utility. So they would sell about 15% more net energy, which is great for an electrical utility, not so great for a gas utility. But it certainly does level the load and reduce socialized costs of infrastructure.
I think one of the things, I think one of the things to add on that, Will, is that for some gas utilities, that's going to be a challenge. The reality is that we, as the ground source heat pump community, want the gas utilities to take an Enbridge approach, because the reality is Enbridge looking at this going, you know what, you're right. You're not going to pay us for a gas meter. You're going to pay us for a geometer. It's the same revenue to them. They have the ability to do it. They have the capital to bring the cost down, and it's going to help all of us. So it's interesting. I feel it'll definitely benefit the utility, the electrical utility, but the Enbridges of the world are seeing the wisdom of, hold on a second. We may not sell natural gas, but we're still going to provide a service to that end user that they need that's going to be to the benefit of Canadians, or in your case, Americans.
Yeah, So it's good for our kids, right? The load factor, really, as we deploy electric heating throughout the grid, it improves the load factor for the utility companies, which makes the grid more resilient. It makes them more financially robust. It reduces, utilities typically are regulated how much money they can make, but they don't have to make as much money, and your rates don't have to go up as much as you improve their load factor. A tiny little 20,000 meter utility in Caddo, Oklahoma, Binger, Oklahoma, excuse me, CK Electric was able to avoid so far $18 million in revenue enhancement. That's 20,000 meters as a result of deploying 1,300 free loops for their customers. $18 million, that's a lot of money. So the numbers add up. It's good for the utility, which means that it's good for you. Next, Mike. So things have changed. There's a long laundry list on the left that you can look at your leisure sometime. Geothermal heat pumps, they are not your father's heat pump. They have changed. Inverter-driven compressors, communicating controls, zoning, you name it. That Symphony system that we've mentioned allows a contractor to look at a heat pump from the front seat of his truck on the other side of the planet and figure out that you need to change your filter, or that your water filter is clogged, or your de-superheater is running while you're on vacation, and so on and so forth. That's terrific. Efficiency, we're going to do a real quick apples to apples. Look at the chart. You see the lowest number on that chart, I think, is 19.4 cooling EER. And EER is like COP, it's just different. The crazy American imperial type units, 19.4 up to 53.2. That's pretty high. Now, let's put that EER in perspective. That's for an air source heat pump, that's 95 degrees. Today in Ontario, that's today's weather, there is one air source heat pump that achieves 16 EER. And it's a 2-ton, a little bitty 2-ton unit at 95 degrees Fahrenheit, period. There's one listed in the world that qualifies. There are no 5-ton heat pumps whatsoever, air source heat pumps, above 13 EER at your current temperature in Ontario today. So not above 13. Most are closer to 10 or 11. You're looking at 19 on a equivalent 5-ton, 19, 36, 28, 45. Those EERs are double, sometimes triple what you get from an air source heat pump, EER, apples to apples. Just wanted to point that out. So Mike, why don't you wrap it up with what it's really like out there?
Yeah, well, I think we're going to finish almost exactly at 5 o'clock, so our job is done. Just sort of to reiterate what Will was saying, you will often hear the community at large, the heat pump community at large, bragging about how traditional heat pumps have caught up with ground source heat pumps. Again, we'll go back to Will's slide a little bit, and I just like to remind everybody that heat pumps, ground source heat pumps, now use ECM circulators. They now have variable speed inverter driven compressors. So all the things that have helped the air source community get their heat pumps so they can operate at the 47 degrees that Will has identified. Well, imagine if you're not restricted by the outdoor air temperature, right? If you start putting in this variable speed technology, that's where you start to see these numbers here that Will just talked about. And just to sort of reiterate his point, this is not your grandfather's heat pump. There are a lot of people out there that talk about heat pumps that have the podium, that are working on research that could even just be 8 years old. Like the evolution of technology, whether it's WaterFurnace or one of the other great brands that are out there, is significant, and it certainly cannot be dismissed. Yeah.
Mike, let me throw a little more gasoline on that fire, so to speak. The numbers that you see on this chart for the ratings for the geothermal heat pumps, we compare those very carefully. The government ratings, we're responsible for those, and we're tested frequently on those numbers. We compare those to the Symphony data that you saw on the earlier slides, and we're extremely comfortable with the actual applied efficiency as it compares to those numbers. In fact, we often exceed it with properly installed heat pumps and rarely go below it. So those numbers aren't just your mileage may vary. You'll probably do better than that.
Well, and that was the findings that Enbridge had as well in their study, right?
And on the other side of that, the day after you install an air source heat pump, the performance will begin to decline. So sorry about that, but that's the way it works.
Yeah. So in the closing minute here, obviously we appreciate everybody joining us. One of the things we wanted to point out, and again, this is from the Dunsky report, is there is a lot of contributing factors that are going to skew what's going to allow Canadians, Americans, our European and Asian friends to adopt ground source heat pumps. And so basically what you're seeing on the right-hand side in the blue is these are the key policies we need to see happen if we're going to see ground source get adopted. So we're going to need federal tax credits. We're going to need ground source heat pump. We're going to need and/or scenario for these ground source heat pump financing. We're going to need tax credits provincially. We need to come up with some sort of recurring incentive, whether that's lower tiered utility rates, which Will talked about and has been discussed at length, whether that's some upfront financing, and again, looking at power rates. You know, secondary policies, that's where you start to get into the federal building code, the national energy code, start to build into the building code and the energy code where you need to meet and exceed certain numbers. You know, I still see it, and I'm sure many of our people who are participating see it. You know, people will get excited that, yep, this is a great install, it meets all the code requirements. I always like to remind people when we're doing code training, don't forget that code is the bare minimum to make sure nobody sues you. We need to see better things put into our building code, our energy code, et cetera. And then, you know, the low priority policies we're not so focused on. Where we see it, where Will sees it, where I see it, we need to incentivize the Americans, Canadians that are going to help us reduce our carbon costs, reduce our infrastructure costs. They need a carrot. You know, they need to have some sort of incentive, whether it's on utility rates or a rebate program. And the reality in Ontario is we are fortunate that stakeholders like the OGA, HREI, and our friends at Enbridge are so interested in seeing how we can move this forward. This misconception that, you know, there's no reason for the gas utility to be involved in this is just that, a misconception. Enbridge has proven they can come to the table, they can bring value to Canada, and they can still have a revenue stream. And anybody who looks at that and goes, that's a bad thing, let's just remember, Will sells heat pumps, Mike sells heat pumps, contractors sell heat pumps. There's nothing wrong with that. It's to the benefit of everybody. So on that note, I certainly would like thank everybody for attending. You know, Will, any last closing thoughts or comments before we move on here?
Thank you all for coming. I really appreciate folks coming to hear this. And if there's anything I can do, any data that somebody would like some backup information on, I'd be happy to share that.
Yeah, Laverne, you're welcome. I see your comment there. We appreciate you coming, buddy. It's been good talking to you lately. We had the question on the system COP performance. They wanted to actually know whether the COP data presented at the beginning included the pumps. It does include the entire system, just as an FYI on that. Just like the, we're kind of picking on air source guys here, but just as they don't include the defrost, we do include our flow center data as part of that. Variable speed flow centers are critical to that. Jacob is saying, is there an ETA on the financial support programs, or where could I get more information on this? Jacob, there was an announcement a little while ago on programs moving forward for retrofit geothermal in Ontario. Enbridge themselves have quite a few programs they're doing for multi-unit residential. If you shoot me an email after this, I'm happy to pass on a contact at Enbridge you can talk to. Or you can call me. I'm happy to talk to you about it. And I think at that point, Will, we've hit most of them. Any of the items that we didn't talk about, as I say, we'll circle back on the questions. We managed to wrap this up at 5:04, so I would say it's mission complete. Thank you again to everybody for attending. Will, my friend, thank you for being part of this. Let's do it again soon.
Thank you, Mike. I appreciate it. Take care.
Thanks, guys.
Bye-bye.